Okay, folks, let's take a few minutes and talk about negatives. So I know that's a confusing point for a lot of people, so I want to spend an extra few minutes just talking about negatives and how you factor out negatives or how you cancel negatives, add, subtract, all that sort of stuff. So I'm going to start with factoring polynomials. Listen, whenever you see a negative in front of your leading coefficient. And so notice a couple of things. This is in descending order. You've got an x squared first, an x to the first next, and a constant last. It's in the right order, but your leading coefficient is negative. The easiest way to factor that is first to factor a greatest common factor. So, we call that a GCF of -1. So we're going to pull out a -1. Now, you know what happens when you factor out a -1? You're really dividing each one of these guys by -1. So that -1 into that negative x squared, when you divide the negatives cancel, that makes that a positive x squared. That 7x divided by a -1 makes it a negative 7x. And then that 18 divided by -1 makes it a negative 18. Now what do? Well, when your leading coefficient is positive like this, a positive x squared, then you can use your normal factoring techniques. But when that's negative, it's a struggle to get it factored. So pull that thing out. Now, y'all, the basic thing, what happens is when you factor out a negative, all the signs change. Look, it's a negative x squared, positive 7x, positive 18 to start with. When we pull that negative out, now it's positive x squared, negative 7x, minus 18. Notice all three signs changed. Okay, now you do your normally factoring techniques. You notice this leading coefficient is a 1. So the rule is we find numbers that multiply to be negative 18 and add to be negative 7. So that's when I would write it over here, multiplies to be negative 18, but also adds to be negative 7. Now, if you're not good at this, you need to go through the list of everything that multiplies to be 18. You're talking 1 times 18, but those don't add to be negative 7. Now, one thing you need to know is when it multiplies to be a negative, one of these is positive and one of these numbers is negative. Therefore, you're actually subtracting to get 7. So 2 times 9, well, there it is right there, right? If I subtract those numbers, I get 7. Which one's positive and which one's negative? Remember, the bigger one should be the sign of the middle term. If the middle term is negative, then the bigger number over here is negative. So we're talking positive 2, negative 9. So I still have a -1 out front. And now I can say this is x plus 2, because the 2 was positive, times x minus 9. If you're struggling with that, go back and watch the videos about factoring polynomials or factoring a trinomial. Now, we don't really need this 1 right here. We do need the negative. So my final result, just factored, is negative out front, x plus 2 times x minus 9. You wouldn't be wrong to write it as -1, but if you're talking about online homework completely factored and completely simplified, they wouldn't put the 1 there because it's an implied 1 when the negative is there. So that's what you should always do whenever your leading coefficient is negative, whether it says factor or you're having to factor to do something else, like is coming up in another problem. So for example, B right here, I'm going to do this guy in 2 different ways because it really depends on the reason you're factoring. Let me say it that way. Now this says factor the polynomial. So when I first look at this, I go, this is a difference of squares because the 81 is a perfect square. Why? Because 9 times 9 is 81. The x squared is a perfect square. Why do I know that? Because x times x is x squared. The negative is required if you factor a difference of squares. So again, you learned this in a previous section. There's a whole section about difference of squares. So if you're struggling with this, definitely watch the video. But when you factor a difference of squares, you need 2 sets of parentheses. One of the factors is a plus and one of the factors is a minus. And it doesn't matter which one you write first. What goes in the first position of both of these binomial factors is the square root of the first value. So the square root of 81 is 9. That goes in the first spot. The square root of x squared, since it's in the second position of your binomial, it goes in the second position of your factored binomial. So x. And there you go. That is completely factored. Okay? But there's another way. I'm not saying the other way is easier. It really just depends on which way you want to look at it. But what if this problem was written differently? What if it was written in the other order as negative x squared plus 81? That is the identical problem. It's just written in a different order with the negative x squared first and the plus 81 second. Now, in this case, you might not notice that it's a difference of squares. Who would, right? But remember the rule, just like in the last problem, if my leading coefficient is a negative number, I need to factor that out, y'all. So the negative needs to come out, and you can write it as a -1 if you want to, which means I change the signs of both of these. Whenever I factor a greatest common factor of a negative out, it changes this to a positive x squared and this 81 to a minus 81. My next step, you always bring down your leading coefficient of -1. And then I look at my parentheses and go, hey, x squared's a perfect square, 81's a perfect square, and there's that all-important minus that's required in the middle to factor. So I have my two sets of parentheses, one plus and one minus. That happens every time you factor a difference of squares. The square root of x squared is x. That goes in the first position. The square root of 81 is 9. That goes in the second position. Remember, we talked about the 1 is not required. So another factored version of this is the negative out front. You don't have to write the 1, x plus 9 times x minus 9. Now, it turns out that is identical to this answer. It's just written in a different form. Why do you say? Well, if you distribute this negative inside right here, that's going to make that negative x plus 9. Negative x minus 9. And let me think through how to say that because you don't see it right off the bat. The 9 plus, don't do that, I'm sorry. The 9 plus x is good as it is. That is the same as this guy over here, x plus 9. But if I distribute the negative into the back one, remember when you multiply, you don't multiply the negative times this one and the negative times this factor. That's not the way it works. You only multiply the negative times one of the factors. And if I multiply this negative times this second factor over here, that'd make that negative x plus 9, which is the same as this guy, 9 minus x. So this is just two different ways of factoring the same polynomial. They are both correct. If you were to type this into your homework, both methods should be correct. The reason I'm showing you both ways is because sometimes when you factor, you might need it in this form. Sometimes when you factor, you might need it in this form. But don't worry if you don't know which form to put it in. Just factor it, and you'll see in the next step whether you should do something to it, if that makes any sense. So let's do some of those problems so you can follow along. Okay, now this problem, I forgot to give you any directions. I apologize, but this just says simplify. Any problem like this would say simplify. What that really means is factor and cancel. So notice that numerator. Notice there's no negative in front of my c squared. No need to factor that out. I'm trying to find numbers that multiply to be -2 and add to be -1. Now again, I'm not going to spend a huge amount of time doing that because we already know how to do that. If you're struggling with factoring trinomials, go back to Module 2 and watch the video for factor and trinomials, and there's really two separate lectures on that. One of the lectures applies if you have a leading coefficient of 1, which we do in this case. The other lecture applies if you had a leading coefficient something other than 1, like 2 or 3 or 5. So numbers that multiply to be -2 and add to be -1, that's going to be a -2 and a +1. So I'm going to say this is c minus 2 times c plus 1. In the denominator, I have, just like my last problem, that's a difference of squares, okay? Because 4 is a perfect square and c squared is a perfect square. Now, if I factor it like I did the last problem the first way, in other words, keep it in the order that it's in, okay? I have my two sets of parentheses, one's plus and one's minus, okay? Now, you take the square root of the 4, that's 2, that goes in the first position of both of those binomial factors. The square root of c squared is c, that goes in the second position of both of those binomial factors. Now I'm looking for common factors to cancel. But I want you to notice something. Check out this. This is c minus 2 and 2 minus c. Are they the same? They are definitely not the same. But they're almost the same, right? They're just backwards of each other. Look, the c is positive here on the top. The c is negative down here in the denominator. The 2 is negative here on the top. The 2 is positive here. Anytime your factors are completely the opposite signs, I'm going to show you the fast way to do it. They cancel each other, but they leave a negative out front. So if I were to write that answer, I could say there's a negative out front, and this is c plus 1 over 2 plus c. Or you could write that as negative out front, c plus 1 over c plus 2, because 2 plus c and c plus 2 are the same. When you rearrange terms, if you take the signs with it, you get the same thing. That should be counted correct. That should be counted correct. Either way. Or you could even distribute the minus sign inside, and it goes only on the top, so that'd be negative c minus 1 over c plus 2. That also should be counted correct. You can't say one of these answers is really better than the other. They are all correct. They are all valid answers. Depending on what you are doing with the problem next might depend on what form you want it in, but all should be counted correct. Now, you know, that crazy trick I just did where I canceled opposites when they're subtracting, if the signs are totally opposite, again, the c is positive here, it's negative down here. The 2 is negative here, it's positive here. That will always work, okay? But let me show you why it works. So let's go back, and I'm going to rewrite that first line that I have, which is c minus 2 times c plus 1 divided by denominator 2 plus c times 2 minus c. Now I'm looking, and I don't see another c plus 1 anywhere. I don't see another 2 plus c anywhere, okay? But this guy right here and this guy right here look very similar. Now, if I factor out a GCF of negative 1, and you know what I mean by GCF, greatest common factor, of negative 1 out of here, okay, watch what happens. So I type a negative 1, or write a negative 1. 2 divided by negative 1 is going to leave me with negative 2. Negative c divided by negative 1 is going to leave me with plus c. Okay, so highlighted, this is identical to that entire statement. Now let me write once again what I have. In the numerator, I have c minus 2 times c plus 1. And the denominator, I have 2 plus c. But you know what? It's on my nerves in the front, so I'm going to put it in the back. There's nothing wrong with that. The order you multiply in is not an issue. I'm going to rewrite my factored version, negative 1 times, now negative 2 plus c. Remember, you can rearrange the terms as long as you keep the signs with the terms. So this is a positive c, so I'm going to put c. This is a negative 2, so I'm going to put minus 2. Now you see what happens. The c minus 2 cancels with the c minus 2. And we're left with a negative 1 in the front, and I have c plus 1 over 2 plus c. Remember, we talked about not having to write that negative, so I cannot write that, and my answer is equivalent to negative c plus 1 over 2 plus c. Or I could say, look, c plus 2, and look at that answer right there. They're the same, except I have 2 plus c here. I have c plus, oh no, I have 2 plus c on both of them. But c plus 2 is totally appropriate as well. Now, do you want to do it this way every time? Probably not. Once you know the trick, and the trick is you have exactly the same numbers but opposite signs. So back to the first picture. Again, making a really big deal about this. This is a plus c and a minus 2. Down here is a plus 2 and a minus c. Those will cancel each other, but it leaves a negative out front. Let's do something like that again. We'll do this several times because that seems to be hanging lots of folks up. So here we go. This is a more basic problem, right? There's not as much going on as the last problem. I have d minus 16 on top and 16 minus d on the bottom. Remember the speech I just gave you? Look, the signs are exactly the opposite. It's the same values, a d and a d and a 16 and a 16, right? But this is a positive d here and a negative d here and a plus 16 here and a minus 16 there. Remember what I told you? They just cancel each other out and leave a negative 1. Well, look, nothing's left there. You know what? That answer is negative 1. Now, again, that bothers folks. People don't like that. So let me show you the long way to handle it. This is d minus 16 in the numerator and 16 minus d in the denominator. Now, this denominator, it's perfectly fine to rearrange the terms. Remember, as long as you keep the signs in front of it. So this 16 is positive. I'm going to put it in the back. This d is negative. I'm going to put it in the front. Look, you can clearly see the signs are opposite. So what would I do? I'd factor out this negative right here. So you have d minus 16 over negative 1 times d minus 16. Remember, when you factor out a negative, both signs change. And this d minus 16 cancels with that one, and that leaves you with 1 on top, negative 1 on the bottom, and that leaves negative 1. Now again, all of this is very accurate, step by step by step by step on purple. But if you know that you have exactly the same factors, but the signs are opposite, you can cancel the entire factors and it leaves a negative 1. If this makes sense and you're comfortable with it, do it that way. If it doesn't, you need to rearrange your stuff, factor out a negative so you feel better about it, and cancel the common factors. Okay, let's do some more. Next problem. Let's change colors. How about pink, y'all? All right. 7y minus 35 and 25 minus v squared. Okay, or better yet, that's not a y, that's a v. 7v minus 35 and 25 minus v squared. I think I need to put my glasses on. So in the numerator, look, I have a greatest common factor. A 7 can be factored out. So I pull out that 7. If I divide 7b by 7, that gives me v. If I divide 35 by 7, that gives me 5. That minus there doesn't change because we just factored out a positive. So there's my numerator factored. My denominator is a difference of squares. Okay, so 25 minus v squared. I can write that as a difference of squares. Remember how to do that? 1 plus, 1 minus. The square root of the first value, 25, goes in the first position. The square root of 25 is 5. The square root of v squared is v. Okay? Now, I don't see a 7 in the numerator. I don't see any 7s in the denominator. V minus 5, I don't see any v minus 5s in the denominator. But you know what I do see? I see the exact opposite. Okay? This is v minus 5, and this is his opposite friend, 5 minus v. Notice again, this is a plus v and a minus 5 right here. I don't want to write it twice because that's not really what's going on. You see what I'm saying? It's a plus v and a minus 5, and this is a plus 5 and a minus v. What did we say about those? Yes, they do cancel, but they leave a negative 1. So that means my final answer, y'all, is negative 7 over 5 plus v, or you could write it like this, negative 7 over 5 plus v, or you can write it as negative 7 over v plus 5. Because you know what? 5 plus v and v plus 5 are exactly the same thing. Because if you take your signs with it, the plus stays with the 5, the plus stays with the v, you rearrange it, and you still get the same thing. So this is perfectly appropriate, and so are these two. All of those should be counted correct in the homework. So I figured the more we do of this, the better you'll feel. Let's factor this numerator, because I can't cancel this w squared and this w squared. You can never cancel part of addition or part of subtraction. That's not allowed. Don't let yourself do that. That means you must factor. I'm trying to find numbers that multiply to be negative 28 and add to be negative 3 because my leading coefficient is 1 right here. So this is the fast factoring technique. Multiplies to be negative 28 and adds to be negative 3, which I had to think about that. How about negative 7 and positive 4, right? So you got w minus 7 times w minus 4. All right, in the denominator, I have a difference of squares. Once again, it makes for good examples, these difference of squares. So I have two sets of parentheses. How do I know that? 49 is a perfect square. The square root of 49 is 7. W squared is a perfect square. The square root of w squared is w. And you absolutely must have a minus to pull this off. So we know it's a difference of squares, which means one's minus and one's plus in your factors. The square root of 49 is 7. That goes in the first position. The square root of w squared is w. That goes in the second position. Then I look for things that match. Okay. Now, w minus 4 doesn't have a matchy friend in the bottom. W minus 7 doesn't either. But then when we look, I see exactly the opposite, right? If I highlight it, show you what I mean. Here's w minus 7. Here's his opposite friend, 7 minus w. What does it require to be opposite? Exactly the opposite signs. So a positive W and a negative W, a negative 7 and a positive 7. What can I do? I can cancel these common factors knowing that leaves a negative 1 out front. So I still have a W minus 4 in the numerator and a 7 plus W in the denominator. Now, you really don't want to put the 1 there because 1 times anything is just that thing. Therefore, don't put the 1. Put the negative out front, and you can say that's W minus 4 over 7 plus W. You're also allowed to distribute that negative 1 into the numerator. So you could say that's negative W plus 4 over 7 plus W. Other correct ways to write that is you could switch that around as 4 minus W, and you could switch that around as W plus 7. All of these are valid correct answers, but not with the 1. So the more problems we do, the better we get. Now this is a division problem. Remember what you're supposed to do for division? You're supposed to keep, change, flip, right? Anytime you divide by a fraction, you must flip that fraction upside down. So look, this first fraction, 11 plus W, he's going to stay just as he is, W minus 9. But I'm going to change my division to multiplication. That's what the keep, okay? Change division to multiplication and flip your divisor. So now 9 minus W, just like it's written in the denominator, now goes in the numerator. And 121 minus W squared goes in the denominator. Now you're allowed to cancel common factors in a numerator and a denominator. But you want to factor everything first. Look, right here, 121 minus W squared, that is a difference of squares. Once again, why? Because they make really good examples when you're dealing with negative factors, okay? So I'm going to factor that before we do anything else. I know you see there's something we can do right now, but I'm going to wait on it, okay? So W minus 9. Over here, I have 9 minus W. I know you want to cancel it so bad. We will. 121 minus W squared is a difference of squares. So I have 1 plus and 1 minus. The square root of 121 is 11. That goes in the first position. The square root of W squared is W. That goes in the second position. Now, look for common factors. Okay? What matches? Well, I can cancel this 11 plus W and that one, right? They're exactly the same. That doesn't leave a negative or anything. But, I can cancel this W minus 9 and this 9 minus W. But now they don't just cancel without a fee, right? There's a negative 1 that goes when I cancel those opposites. Now, if you didn't want to do it that way, you could factor a negative 1 out of here, and that's going to leave you with negative 9 plus W, which is the same as W minus 9, and then a negative out front, which is that guy right there. Now, to wrap him up, what do we have left? Well, I have a big old negative just sitting out front because of that negative 1. Both of my numerators are gone, so that leaves a 1. And the denominator down here, that's just 11 minus W. Now, that's an appropriate answer. I don't find a thing wrong with that. If you wanted to take the negative to the numerator, you could, and you could say that's negative 1 over 11 minus W. You could even take the negative to the denominator instead and leave the positive 1 on top and say that's a negative 11 plus W, right? Because it distributes into both. Or you can even leave the 1 on top and say that's W minus 11. All of those are correct. I promise you not one is better than the other. It's just distributing the negative inside. And say you were taking a multiple choice test, you need to know how to manipulate these negatives, because what if, this last one was your correct answer and these other options weren't available? So you would need to know how to distribute that negative inside. But y'all, there's nothing wrong with this first result right here. I've got 3 more examples, but you can always stop the video if you have had enough. So more negative stuff. Now we're adding, right? Now whenever you add, you must have a common denominator, right? These denominators must match. It's like adding apples to oranges if they don't match. Or like when you add 1/2 plus 1/3. Well, 1/2 of the pizza is a completely different size than 1/3 of the pizza. So we can't add them together unless they match. But when I look at these denominators, they kind of match, right? This is a positive 6w on the left-hand denominator and a negative 6w on the right-hand denominator, and a negative 1 on the left-hand denominator and a positive 1 on the right denominator. They're opposites of each other, right? That's what we've been dealing with every problem we have done so far. How could I get them to match? Well, what if I factor a negative 1 out of this second denominator over here? It's going to match the first denominator, but just watch and see. So the first denominator, y'all, the whole thing, the whole fraction, I'm leaving alone. 18w over 6w minus 1. It's perfectly fine as is. Plus 3w minus 2. Hey, he's perfectly fine as is also. But look, this guy right here, let's factor out a negative 1. So if I pull out a negative 1, that's going to make that 1 that's positive is going to turn into a negative 1, and that negative 6w is going to turn into a plus 6w. That's what happens when you factor out a negative 1, right? All the signs change. Now you might be looking at this and going, no, it looks worse than it did to start with. Hey, I agree, watch this. So I have 18w over 6w minus 1, still leaving the original fraction alone, plus 3w minus 2 over negative 1. Now, this negative 1 plus 6w, wouldn't you feel better if it was written as 6w minus 1? And is that the same thing? Well, yeah. You can rearrange your terms. You can write the second one first and the first one second, as long as you leave the signs in front of them, still in front of them. So that plus 6w has to remain a positive 6w. That negative 1 has to remain a negative 1. Now look, the denominators almost match. This negative 1 is in the way. You know what I can do with it? Right here. I can change this plus problem by taking this negative up to the top, and it turns now into a minus problem. That's how you handle that negative 1. So you have 18w divided by 6w minus 1. Now my addition problem is a subtraction problem. I still have 3w minus 2 in that numerator, and now I have 6w minus 1 in that denominator as well. What's the fast way of handling it? Hey, change the second denominator to match the first denominator if they're opposites, and that changes your operation from addition to subtraction, or had it been subtraction, you would change it to addition. But now, if you don't see that, hey, there's nothing wrong with factoring out a negative 1, pulling that negative in front, which changes this operation, and now you match. Now, how do you do the problem? I see a lot of mistakes with subtraction problems, so watch this. I'm calculating 18w minus this whole numerator, 3w minus 2, over common denominator, 6w minus 1. Why did I put those parentheses there? Because you know what? That negative has to distribute inside. This is 18w minus 3w plus 2 divided by 6w minus 1. And 18w minus 3w is 15w plus 2 over 6w minus 1. Now, if we could factor either the numerator, the denominator, or both, I would. But there are no greatest common factors. There are no exponents, so I know that I'm not factoring a trinomial or a difference of squares. So nothing factors and cancels. I'm finished with that problem. So to get denominators that are exactly the opposite to match, factor out a negative, change the operation in the middle. Next to the last example I have for you, hey, check out these denominators. I got an a squared minus 4 and a 4 minus a squared. Do they match? No, they don't match, right? But they almost do, because this a squared is positive. This a squared is negative. Notice the a squares are opposite signs. This 4 is negative. This 4 is positive. The 4s are opposite signs. Remember what we said about that? If they're opposite, just pull out a negative. We're going to do exactly what we did a minute ago for the last problem. So this is a squared plus 3a. I'm going to leave the a squared minus 4 as is down there. Minus 3a minus 8. Look, I'm going to switch this around, and I'm going to make that a negative 4 and a plus a squared, but the only way I can do that is to factor out a negative 1. Now what happens is that negative 1 changes that minus to an addition problem. And now I have a squared plus 3a over a squared minus 4. On the other side, I have 3a minus 8, just as it was. Instead of writing that as negative 4 plus a squared, that's identical to a squared minus 4. Now look, I'm matchy-matchy. I got what I need, right? As long as those denominators match, then I'm allowed to add the numerators together or subtract, whatever applies. It's addition in this case, because that, to get these to match, it changed that subtraction to addition. Now I'm going to add like terms. So a squared, there's not another a squared over here, so that just leaves me with a squared. 3a plus 3a is 6a, and then that leaves me with minus 8 divided by my common denominator, which is a squared minus 4. Now, that's my answer, but it might simplify. So you should always attempt to factor and cancel if possible. My numerator, what multiplies to be negative 8 and adds to be 6, and that's going to be anything? I mean, 2 and 4 multiply to be 8, but one's positive and one's negative. You know what? Nothing cancels here. If that were a negative 6, no, if that were a plus 8, that would work. Is that a plus 8? I'm trying to make it, I'm trying to find any possible way that I made an error, and that should actually be a plus 8. But we didn't. We pulled down the 3a minus 8. I switched signs here, or factored out a negative 1. That changed that to addition. Yep, there is no plus 8 in this situation. So this does not factor, so there's no point in factoring the denominator, which would be a plus 2, a plus 2, but the numerator does not factor. All right, got one more problem for you, and it looks like a pretty big one. Okay. Again, what's the point? My denominators have to match to add or subtract. The only time your denominators have to match is when you add or subtract. Not when you multiply and divide. You just factor and cancel when you multiply and divide. But when you add or subtract, they must match. Hey, look, these almost match. Do you remember the trick? And we don't have to take up so much space to do it. The trick is, if the signs are exactly the opposite, plus b squared, minus b squared, those are opposite. Negative 49 plus 49, those are opposite. I can switch this one around, if I could get my pen to write. I could switch this second one around to match the first one. I can write it as b squared minus 49. But to do that, I factor out a negative, which makes that a plus. Now, the fast way is you factor a negative 1 out. And that's going to make it negative 49 plus b squared, which is going to make that a plus. And you switch it around to read b squared minus 49. But after you do a couple of them, why do that every time? Okay, so here we go. In the numerator, I have 2b squared plus 3b minus 15 plus, now because we're adding, it's an easier problem. You don't actually even have to write the parentheses I just wrote. But now, y'all, if it was a subtraction problem, which it was originally, but because the denominators were opposite, now it's an addition problem. But had that still been subtraction, it would change every one of those signs after the parentheses. Okay? Denominator is just b squared minus 49. Now I'm going to add like terms. And these parentheses here are not really required, again, because there's an addition in the middle. But 2b squared plus b squared is 3b squared. 3b plus 16b is plus 19b, and negative 15 plus a negative 1 is negative 16, and that's all divided by b squared minus 49, my common denominator. Now, you know, that's the answer, but the fact is, does that fraction simplify to lowest terms? Can I cancel common factors? And what you would have to do is attempt to factor the numerator. Now, y'all, this goes back to factoring polynomials with a leading coefficient of something other than 1. Now, the trick that I did is I multiplied this 3 times negative 16. So first, tell me what is 3 times negative 16. And you get a negative 48. A lot of times I write it at the top of the triangle. So I need numbers that multiply to be negative 48 and add still to be the middle number, which is 19. Now, you just start thinking about things that multiply to be negative 48. Now, but the first look is 3 times 16, right? Multiplies to be 48 and adds to be 19. But kind of like a problem we did just a minute ago, even the last problem, excuse me, the signs aren't right. So we need something that multiplies to be 48 negative. So one's positive and one's negative, and adds to be a positive 19. So I keep thinking about my numbers that multiply to be 48, like 24 times 2. But that wouldn't add to be 19. We did 16 times 3, right? But one's positive and one's negative. That would add to be 13 and not 19. What else gives you 48? 12 times 4. Now that doesn't add to be 19. 6 times 8, that doesn't add to be 19. 4 times 12, already got that listed. Probably should have done these factors in order, like 1 times 48, that doesn't add to be 19, or subtract to be 19. 24 times 2, 3 times 16, 4 times 12, 5 doesn't go into 48, 6 times 8, 7 doesn't go into 48, and 8 times 6, and that means we've started over. So turns out, this does not factor further, and that's my final answer. So I hope this helped you with negatives and maybe putting them all together in one video to point out the different types of problems. But now if you have a negative problem that you are just stuck on and you're not sure what to do with it, send it to me. I'll make a short video or just add it to this list of videos. Maybe that'll help out everybody that's struggling with negatives. I hope you all have a wonderful day.